Well, hello and welcome to this exercise in which we are trying to find the domain of a square root function. Okay, here we go. Right, we want to find the domain of the square root of 1 minus x minus 2x squared. In other words, we want to find the values of x for which we cannot have a negative number under the square root sign. So now to do that, I need to factorize 1 minus x minus 2x squared. So I need to do that first. And to help me do that, I've written it down as 1 plus x minus 2x minus 2x squared. Now, that makes it easier to factorize, well, for me anyway. I can now go ahead and factorize that because I've now got two groups. I've got a group with 1 plus x and the other group of minus 2x squared. So when I factorize, I end up with 1 plus x for the first group, minus 2x into 1 plus x for the second group. So when I combine both, I end up with 1 minus 2x into 1 plus 2x. Sorry, 1 minus 2x into 1 plus x. So I can then write my function as f of x equal to the square root of 1 plus x multiplied by 1 minus 2x there. So because looking for the square root here, this expression cannot be, when you plug in x values, this expression is not allowed to be below 0. Okay? Right. And so either 1 plus x and 1 minus 2x will be negative, give us negative values, or 1 plus x and 1 minus 2x will give us positive values. So we're now in a position to find the critical points. So we can say that either 1 plus x is equal to 0 or 1 minus 2x is equal to 0. And our critical points are x is equal to half and x is equal to minus 1, which I got from 1 plus x equal to 0 and 1 minus 2x equal to 0. So our critical points are x equal to half, x equal to minus 1. So now if I draw a number line like so, I'm going to indicate there'll be three sections here. The boundaries will be at minus 1 and 0.5. So I want, there are three regions here. I want to test in which region the x value will be valid for this square root sign. So if I try first of all f of minus 1, if x is minus 1, so 1 minus minus 1 will give me 2, 2 minus 2 will give me 0. So f minus 1 will give us 0. So minus 1 is valid. Then let's try f is equal to minus 2. Now if x is minus 2, 1 minus minus 2 will give me plus 3. And 2x squared will give me 8. So 3 minus 5 will give me, 3 minus 8 will give me 5. So f into f of f minus 2 will give me a value less than 0. Now similarly, if we plug in the value of x is equal to minus 0.5 into 1 minus, if we plug it into 1 minus x minus 2x squared, we get a value greater than 0. And if we then plug in x is equal to 0, again we get a value greater than 0 because 1 minus 0 minus 0 will give us 1, which is greater than 0, so that's valid. If we then plug in x is equal to 0.5, we end up with 0. Okay, and then if we then try, let's try f is equal to 1. Now 1 minus 1 will give us 0, 0 minus 2 squared, so 0 minus 2 will give us minus 2. So f minus, so if x is 1, that's not valid. So it seems to us that in this region here, from minus 1 to 0.5, including 0.5 minus 1, that this region, all the x values in this region are valid. The x values in this region where x is less than minus 1, these are not valid. The x values in this region are also not valid. So we end up with the domain being x is greater than or equal to minus 1 or less than or equal to 0.5. Now to confirm, if you sketch a graph of if you sketch a graph of the square root of 1 minus x minus 2x squared, you get this. So this in effect confirms what we got from our calculation here. Now I hope all that made some sense, and please subscribe, and thank you for watching, and bye bye now.